other good fast food, actually good.
Yeah, see, we can't have upper echelon fast food. That just doesn't work.
Get out of here.
Yeah, you need to have either fast food garbage or food. You can't have this premium fast food thing. It confuses people.
Chick-fil-A and Popeyes is a pretty good fast food.
That's somebody checked.
Yeah, well, that's the problem.
I mean, I think it's pretty good.
That's why you don't see them all over the place. All right, so let's pick up where we left off from last class. We were getting ready to do some debit stuff, right? All right, everybody remember the midterm is due by midnight tonight. Who's taken it already? All right, how bad was it?
I mean, if you've been doing homework, paying attention, you'll know what's going on.
All right, so not horrible?
I didn't think so, at least. I mean, it was...
Horribly unfair?
Yeah, pretty much.
Good. Good. Do remember that I have that policy that if you do better on the final exam than you do in the midterm, I'll replace your midterm exam grade with whatever you get in the final. So if you completely bomb the midterm, that can still turn into 100. All right, so let this be a litmus test for where you are. And I'll have them all graded by the end of day tomorrow because I have to turn in midterm grades. All right. So, and then how was the tech talk last night?
It was good. Didn't like how it was extended by, I think, 30 minutes.
I don't know. It's supposed to be 6 to 8. It only went 5 minutes long.
I felt like it kind of got dragged out, though. I feel like we had a good ending point at around 7:30.
Chris asked us afterwards, we were like,
Yeah,
So I will
I
say
agree.
that was
I found it pretty interesting getting the former computer science students' take on a single employer from some different perspectives. You know, you're looking at Acuity as just an example employer. Not all employers will be like that, but I think it is interesting to hear from folks that were in your shoes not that long ago, kind of talking about their experience there. Yeah.
This is the best. I think this is probably one of my, I would say, best TED Talk in terms of content. This was absolutely vital. These aren't just like, these aren't adult. I mean, granted, the people that we've seen aren't like, I don't know their exact age ranges. I can't.
Right. You're so far we've heard people that have been at these businesses for 20 years.
Yeah.
Something like that.
From a young person.
Yeah, not somebody who was sitting in your seat a year ago.
Right.
Or 2 years ago, you know, that kind of
I
stuff.
think that's what makes it
Yep.
very special. And I
Yeah.
think that they gave really good answers. And yeah. Or of course, give really good answers. Those are your standards.
That's right. Okay, so let's go back to our code here. Oh, this thing reset? Good. Hopefully we lost everything. That's what I'm hoping. Fingers crossed. All right, so we were working on this idea of a debit, where a debit's going to have an amount associated with it, and it's going to have a month. And what we want to do, I don't think I've put my debits in yet, have I? So in my driver here, so what we want to do is we want to simulate Pastor Smith putting an initial, so day one, when he graduated and he wanted to join the Alumni Association, he gave them $100 for that year. Presumably, it was an option for him to give them $1,300. That's kind of what he indicated, that he wished he had gone back and given them $1,300 for a lifetime membership. So he gave him $100 day one. Now he has $1,200 left. So we're going to have him invest that in the very first month, the rest of his $1,200. Then what we're going to do is we're going to have him debit every 12 months. So in month 13, we just keep adding 12 to it, right? So month 25, so on and so forth. All right, so we're going to create a debit. We're going to debit the account an amount of money, so $100 for that month, and then we'll jump the month ahead by 12. All right, our total investment time is going to be 156. We're going to call get current value on that. So now we're at the point where we need to update get current value to take into consideration any debits that should happen that month before we calculate interest. All right. So if we go back into let's look at our investment and look at what debit account does. So debit account is kind of like we did for add contribution, but for add contribution, we passed in a new instance of contribution. What we did for debit account is kind of the alternative, where we pass in the pieces of information that are required for creating a debit. And then inside of investment, we create a new debit object. Okay? So you can decide, do you want to create the instance out here and pass the whole instance in, or do you want to just pass the two pieces of information in and under the hood have it magically create the instance? Probably the second approach is maybe a better programming practice, but not drastically so. Either one of them is reasonable. If we're going to kind of give a rule of thumb, we might say out here at driver, we should assume whoever's writing this maybe knows the least amount about how our objects are built. All right, so they're calling upon our tools. They're calling upon contribution. They're calling upon debit. Really what they're doing is they're calling upon investment and letting investment, we are debiting our investment by how much and in what month, and then whatever that means under the hood, our code does. All right, so what we would call that, so we're going to give ourselves a rule of thumb. Main should read as much like English as possible. So how do we accomplish this? We encapsulate as many details, and here for encapsulate, we're going to say hide. Fancy word for hide. Encapsulate as many details of our logic inside of the objects that go into our solution. Okay, so we want to hide as many things as possible so that in the end, main looks very simple. All right. So we make a single contribution, then we're making 13 debits. And remember, with our investment solution here, we kind of pre-plan everything, right? We say, this is what I'm doing. I'm giving you $1,200 day one. Then I'm going to take away $100 on month 13. I'm going to take away $100 on month 25, so on and so forth. So we're planning out our future here. Then we're saying, go. Run the investment simulation. Okay? So we need to go into our get current value here in investment. And what this guy's going to do, here's our earning percentage. That's the 8% divided by 12. All right. We need to call execute debits. So execute debits is going to go through, and any debits that should occur on this particular month need to happen. So we have, this is the number of months. So this might be like our 156 that's coming in for after how many months are we calculating our investment. So this is going to go from month 0 to month we actually could probably do, yeah, this is for how many months. So we're going to do this 156 times. That's fine. So 0 to 156. Now we're going to go ahead and we're going to execute debits for the current month. Really, this is passing in a 0 right now. We probably would always want to pass in +1 to that because our debits were created with month 12, month 25, so on and so forth. So we never have a debit on month 0. So I'm going through and saying, here's the number of months I'm calculating interest for. I can do it this way, or I can say, here is the per month I'm calculating interest for. I'm going to go all the way up to per month being, oh, here, I'm going to show you what I did. I think I showed you this last time. Start this off at 0. I mentioned in class last time the idea of refactoring and renaming. And if you were paying attention last night, one of the speakers mentioned refactoring. He used that same term. So it's a software engineering term. So I want to rename my variable I here to be called per month, because I want to give it some more meaning for how we're going to use it. So I'm going to right click on this guy. I'm going to go down to refactor. Refactor is a software engineering term that says I want to make some changes to my code. There's a bunch of stuff we can do here. So like changing method signature, things like that. But we're just going to rename our variable and we're going to call this guy per month. So now any place we were using I in this scope. So notice that it's smart. It didn't change the I's down here. It just changed the variable I that was available in this scope here in this for loop to be now called per month. So I don't have to go and find all the individual places that it was in. Make sense? All right, so this kind of falls into that category. We want variables named things that are most meaningful to us. So we're going to say we're going to start off in month 1. We're going to go all the way up to and equal to month whatever after how many months was. This is still going to go through the identical number of times. So 0 to less than 156 is the same thing as 1 to less than or equal to 156. This loop will repeat the identical number of times. But now, per month is the correct parameter to pass in to execute debits. So what we're saying, so what do we want execute debits to do? We want it to go through, and before we apply any interest to our money this month, we want to go through and start removing money from our contributions. Does that make sense? All right. So here's execute debits. Execute debits is going to take in a month number. All right, and last time we discussed that we can make the assumption that at most we'll be doing 1 debit per month. Okay, so we'll go ahead and create an empty debit. What does this loop do? That guy's called a ForEach loop. How does that work? The books talked about it, but I introduced it for the first time last class. The book maybe refers to it as an iterator. The book used that term? Does the book use that term, iterator? This guy right here. So here, let's just put it on some slides. So we're going to say lists, like array list, follow an. Actually, here, let's fill in some blanks from last class. The book has not talked about interfaces yet, has it? All right, so we have something called interfaces. Josh Curcio misspoke a couple of times after they first said this word and called them implementations. But what we're talking about is interfaces. An interface is like a class, but without an implementation. Okay, well, so that seems kind of useless on the surface, right? It's like, okay, well, so I'm going to write something like, here we've kind of planned out our investments, right? We've decided that, here's an investment. An investment will have a collection of contributions and it'll keep track of the current balance, something like that. We might call this something like an interface. It's an idea about what something that is an investment must have. But it does not say anything about the implementation of it. So we can have 5 different objects that are compatible with the investment interface. That is, all 5 of these objects have a collection of contribution objects. All 5 of these objects keep track of the current balance, blah, 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 that kind of stuff. All right, but the interface itself does not dictate what that implementation must look like. So it allows us to have kind of things that are compatible with other things. You go into a grocery store or something like that, all the boxes have barcodes on them, right? Why? How does General Mills cereal put a barcode on there and then at the same time pick your favorite Hormel chili or something like that also has a barcode on it? They're not made in the same factory, or they might be. Everybody, you got this whole conglomerate of companies that might all be owned by some top level thing. But let's assume they're made by a whole different company. Why do they put that barcode on there? What's the purpose of the barcode? Go ahead.
It's so that they can apply a value to that barcode, to the barcode data that's on that.
Okay.
So like at a store, they have the barcode so that they can assign those items to.
Okay. So the barcode holds some information.
Yeah.
There's some information encoded in that barcode, right? So how many of you can read a barcode? I mean, as a human being, glance at that barcode and read the information off of it.
No, that's impossible.
I don't know if it's impossible, actually, but we are not compatible. Our eyes are not barcode compliant, right? Okay, we're not compatible with reading barcodes. So how does the grocery store read the barcode? How does Target read the barcode? They have a scanner. Is that scanner made by General Mills? Is it made by Hormel? Who makes a scanner? Some other company, right? So how does this scanner made by another company work with the barcodes that are on all these different food products? You're right. There's an interface. They've defined an interface of what a barcode is. And then that barcode reader has implemented a way of reading things that implement the barcode interface. So that box of cereal has a barcode on it that might have more information on it than maybe the Hormel chili. But it, at the very least, has the core information that all barcodes must have. Make sense? That way your barcode reader can scan any one of those food items and pull in the information from the barcode. Interfaces let us do that. Interfaces let us say, here is something that must follow these guidelines. But I'm not going to dictate how you follow those guidelines. I'm just saying these are the guidelines you must follow. And if you follow those, you can do other stuff too if you want. But if you follow those, you are now compatible with things that have been created with that interface in mind. The barcode reader, right? You go and buy this barcode reader, what can it do? It can read any barcode that follows the barcode standard. So we can think of interfaces as almost like a standard. We'll call this barcode example from class. That make sense? All right, so that's what an interface is. An interface is a standard, and it's represented as an unimplemented class. But instead of saying class whatever, we say interface barcode, for instance. All right, and we're not going to write our own things of these yet, but this just gives you an idea of where these guys come from. So questions on the high level of interfaces. We kind of get where this fits in the world maybe, and remember, programming languages have the job of allowing us to solve problems in a similar way to how we solve them as people, solve them in the real world. So this idea of having things that are compatible with a broad classification of things, that's something we run into. Barcodes is just one quick example, but we can sit here and in 20 minutes come with a whole bunch of examples of things that are like that, right? Our soda machine in here. That requires all the cans you put in there being a certain shape and size, or at least within some sort of threshold, right? You can't put a 2-liter bottle of soda in there, it's too big. Okay? You can't open it up and dump it in there. Well, you could. It would probably be bad, but, that's good.
So could you say interfaces don't have methods since they don't say how to do interfaces?
interfaces can dictate a method. So for instance, maybe anything that is a barcode will have a read data method, but it wouldn't actually implement the method. But it might dictate that it must have a functionality called read data that the barcode scanner can call, for example, and it will return a string, let's say. But it doesn't dictate what that method will do. It just says the method's called this and it returns this kind of animal.
So it's like if it didn't have the main stuff in it, that's the implementation side.
Correct, yeah. So if we came in here, we would say, like, this is all implementation stuff. Where we could have an interface that says, hey, you must have a method called execute debits that takes in an integer and spits back nothing. What we can suggest kind of the thing that method should do, but nothing keeps one of these food item places from putting a barcode on a thing that just spits out gibberish, right? Look, what we're giving you has nothing to do with this product. It is the original source code for Super Mario Brothers that you're scanning off this thing. That is what it is in binary. All right, so there's a reasonable implementation of it, but all we're saying in an interface is we're saying you must have this that takes an int and gives you back this. Do what you will with that. All right. So we can connect that to real life and say, oh, well, that's the type of thing that, we have standards for things. When you get a new, if you get a jump drive, right? You assume that that's going to be able to plug into your computer through a normal USB port, correct? That's a standard. So when you order it, you might be interested in whether it's USB 2 or USB 3 because those are also standards. There's a USB 3 interface that says this is what USB 3 means, but not all things that are USB 3 operate at the same speed. But the interface dictates that it can operate. It can do these certain things. It can read more than one thing at once. Stuff like that. If I ordered a jump drive off of Amazon for this computer, I would either have to assume I was getting a normal USB, so I have this adapter dongle thing here where it has USB 3 ports on it, and I could use it on that. But if I wanted to get a special USB thing, I would have to get a USB-C compatible jump drive. I think they do, but nobody has them yet. Nobody uses them yet. So it's one of those things where Apple, as they usually do, kind of are about a year ahead of most places for like pushing a new interface, and then everybody else either jumps on board or goes against it. Sometimes it's worked, sometimes it didn't. Apple pushed FireWire for a long time. That never took off mass market, but USB-C has. So I think if you fast forward, anybody who has a newer laptop, regardless of who made it, has a USB-C port on it, or a newer PC, regardless of who made it, has a USB-C port on it.
I have a charger, which is USB-C and all USB-C.
Mm-hmm. Go ahead.
So what exactly about the barcode example makes it so that it doesn't require implementation?
Well, it does ultimately require an implementation. So the General Mills, they put a barcode on there, but they have to, make sure they encode at least the 5 pieces of information that all barcodes must have, let's say. And Hormel Chili, they put a barcode on their thing, and it has to follow, the thing that the barcode readers know how to read, and it has to have at least those 5 pieces of information. Maybe Hormel Chili puts an additional 2 pieces of information on there, but they at least have to have those 5. All right, so those companies are saying, here's our barcode. We adhere to the barcode standard. We are giving you at least those 5 things that you're asking for. The barcode reader now is an actual implementation. It says, I know how to read barcodes. So I'm going to read those 5 pieces of information, and then I might look for some extra stuff, if there's extra stuff there. But at the very least, I'm going to look for those 5 pieces of information. That's an implementation. They actually built the little machine thing, right? The scanner gun. So inside that, it's saying, I'm going to read these 5 things, and here's how I'm going to read those 5 things. That's the implementation. So they actually wrote the code. They built the circuits for it to walk up, hit the button, and it reads from a barcode. Make sense? All right. So, and that's kind of the driving force. We don't necessarily see them that much now, but where did QR codes come from? We still see them, but they were very popular for a period of time. They're less popular now. Why did we have QR codes? What problem was the QR code solving? Go ahead.
Typing in a big web address.
Okay, well, why didn't they do it with the barcode? That would have made sense, right?
Yeah, I don't know if this is the case or not, but it might be more universal, where it might be easier to read on like a smartphone camera versus a smartphone camera might not be the best at reading a barcode.
Yeah, that's it. So the early days when people would have a smartphone, they wanted to walk up and scan something, our cameras on our smartphones weren't good enough. They didn't have the resolution to be able to take good pictures and also scan barcodes. So we needed a new standard, a new way, a new thing that a smartphone camera could scan. That makes sense? But now, for instance, you use the Amazon app on your phone. You can scan barcodes. Because now our cameras on our phones are 10, 12, 15 megapixel cameras. They're now good enough to scan a barcode. They're high enough resolution, which is why QR codes are less popular now. We're not seeing them thrown on everything because you no longer need a QR code for a phone to be able to read it. That makes sense? That isn't to say places don't still have it because it just became kind of somewhat commonplace. But now it's one of those things where our smartphones can read a QR code from across the room with a digital zoom, which doesn't actually move the camera. That's all just processing software. So our cameras have gotten so good, and every year that's the new thing, right? Whatever the latest flagship phone that comes out says, our camera is better than last year's camera and is better than the other guy's camera. And if we can't make it better, what do? We put more cameras.
iPhone 11, 3 cameras.
Yeah, well, mine has let's see, 3 cameras back here, 1 camera in the front, and then a 3D scanner back here. Because you just need that on a smartphone, right? You need to be able to go around objects and scan it in 3 dimensions. It would be awesome if it worked well, okay? But, usually 3D scanners, what you do is you put something on a pedestal, and then you have a scanner, and the thing sits completely still. And then the thing goes around it, is completely still, right? Okay. Well, I have tremors in my left hand anyways, okay? But I have not found that to make my scans drastically worse, right? As human beings, as we're walking, we're moving around. It's a stupid idea, is what it is. You can 3D print some stuff that will hold your phone and create your own scanner thing, which let's call that okay. But yeah, it's a gimmick, right? It's like nobody else has a 3D scanner, so we got some space because this phone's the size of a TV screen. Put another camera on there.
Can we 3D scan your head and 3D print it?
Potentially, yeah.
Do you think that'd win the contest?
What, for Halloween?
3D printing contest.
Yeah.
Well, no, I get it, but isn't the thing supposed to be? Was it Halloween as the theme, or is it
It's
fall?
Right behind you. It's literally right behind you.
Well, yeah, but I don't have eyes in the back. Well, I do, but I don't like to show off.
You turn around and look at it.
I've
says
seen it.
Fall and Halloween.
Fall and Halloween. Well, but I mean, the contest is over, right?
It's still going on.
The 21st.
21st.
But have you actually taken a look at what is sitting in Mr. Gonzalez's big, beautiful black hands? It's 120 skulls.
I replied to you on Slack.
Yeah, we put on there. That's where the goalposts are, people.
No. I replied to you that it's not an actual contest.
You don't think so?
No. I said no. You can't enter. Mr. Gonzalez can't enter it.
Why?
Y'all are-
Because because we don't allow professionals. It's kind of like we don't let professionals compete in the Olympics.
No, dog.
We do now, right? For years, like when I was a kid, you didn't have the professional basketball players, for example, playing in the Olympics. You had amateur, and it was way less exciting. Then we had the original Team USA that was basically a legendary, Jordan, Larry Bird. They were beating people by 700, 800, 700 or 800 points, something like that.
80 points.
No, they just stopped trying. It was alley oops from half court. I mean, it was ridiculous. Now every sport has professionals, right? Hockey lets pros, and it's just the new standard. Yeah. So in any case, do we understand what interfaces are and how what role they play? Okay. We're not going to be writing interfaces yet. In fact, we may not even write interfaces in this class. But we are actually currently using an interface by accident. So where I was going with this is, and here I'll show it to you in the documentation. Well, there's our 3D printer going. So we're going to do array list, Java. All right. All right, so here is the inheritance model. And we're going to be talking about inheritance shortly. But here's the inheritance model where an array list is an abstract array list, which is an abstract collection, which is a generic object. All right, so that's where array lists fill in terms of, we have the idea of a car, and then we have a truck, and so we have an automobile. Off of that, we have a truck. Off of that, we have a Ford. Off of that, we have a model number F-150 or something like that. All right, so this is the inheritance model. But then we have these implemented interfaces. And notice we have several of these guys here, but the one we care about is this iterable interface. So when we click on the iterable interface, this guy says he must have a function called ForEach. He must have a function called iterator that returns something that's an iterator. Ooh, I like that word, splitterator. That's just fun to say. I don't even care what it does. Like you're at Home Depot and there's like a sale on an end cap for something called the splitterator, you buy that. Right? This creates a splitterator over the elements described by this iterable. Okay, what's a splitterator? Oh, it's traversing and partitioning. So it kind of goes through a collection of stuff and then chops them up as it's going.
Yeah.
Yeah, that's a wood chipper is what that is. Right? that's, yeah, Mr. Gonzalez asked for one of those for Christmas. Why did he need a V12 engine on it? I don't know. I don't ask those kind of questions. All right, so in any case, this idea of the iterable interface says it must have these couple of methods. All right? Now, the idea is that anything that is iterable is compatible. So think of iterable like our barcode example, right? This is barcodable, right? So we have this barcode that says, here's the standard. Barcodes must do this. This is a standard for iterable. All iterables must do these couple of things. All right. Now we can go and get the tool that is a ForEach loop is kind of like our barcode scanner. This guy knows how to go through collections that follow the iterable standard. Make sense? So whatever I pass here on this side must be something that is iterable. So I can't give it something that's not iterable, that doesn't follow that standard, because this ForEach loop is going to assume that it can call those couple of methods to get the pieces and do something with them. Okay? So we can use a ForEach loop whenever we are dealing with something that is iterable. And what we do is we say, this something is a collection of these kinds. That's our generics. You heard generics come up last night. That's the idea of having a generic way of holding things, but then giving it a definition of the kind of values you'll be putting in and the kind of values that should automatically come out. All right, that's the angle brackets. That's our generics, those angle bracket things. All right, so we have a collection of debit objects. So it's an array list of debit objects. We just saw that array lists are compatible with, they implement the iterable interface. Make sense? And it just so happens that Java provides us a tool called a ForEach Loop. This is like our barcode scanner that knows how to work with things that are iterable. Got it? Go ahead.
The iterable interface had the 3 functions.
Mhm.
We're using the for each, but don't you have to use the other 2 then? Isn't it like required for interface?
Well, the ForEach would use whatever it needed there.
Okay.
Yeah. So I mean, we are dictating that the implementation of a ForEach. You know, just like we don't dictate what, you know, I assume you can go out and shop for UP, what's it called? The barcodes. You can go and shop for barcode scanners, right? And they're not all equal. Some barcode scanners can do more than other ones. Some have more onboard memory. Some maybe do some extra scanning type things. Some might be compatible with standard barcodes and then maybe are compatible with like a newer, more verbose standard for barcodes, something like that. So this for each loop is an example of one of our implementations of a barcode reader. And this guy, he can only assume that the iterable he's working with has those 2 or 3 methods. He can choose to use all 3 of them. He can choose to use 2 of them. He can choose to use 1 of them. He could choose to ignore it. Just says, look, I said I'm compatible with iterable, but I'm going to pretend like I don't know what that is and instead just make stuff up. It could do that. Okay, so by saying this guy is compatible with working with things that are iterable compliant, just says that we're not dictating what the implementation ends up looking like. That's out of our control. We just have our barcode scanner here that knows how to scan things that have implemented the barcode interface. All right, or in this case, we have our for each loop that knows how to loop through every element of something that has implemented the iterable interface. So a for loop, by definition, goes through some collection some number of times. So this guy's going to go through 1 time for each of the elements in that collection. And each time through, he's going to set this variable, which I call D, we can call it whatever you want, but he's going to set that variable equal to the next value he retrieved from this collection. And then inside the loop here, we can ask the question, we can operate on that instance of what came out of our collection. So the first time through, D will be the first element that was in the debits. The second time through this loop, D will be equal to the second element that was in the debits. Next time, it'll be equal to the third element that was in the debits. So what we have given up here is we don't know which element we're currently looking at. We don't know that we're looking at element 0 or 1 or 2 or 3. We just know we're looking at the next element. So it's a convenient way of going through every collection, looking at it, doing something with that, tossing it to the side, picking up the next one, doing stuff with it. All right, that makes some sense? All right, but beyond what a for each loop does it make sense how a for each loop works. It functions because it's compatible with iterable things. That's what it eats. We have to throw it something that is an iterable here. Otherwise, it'll say, I don't know how to deal with this. Right? You can't put a brick into your blender, okay, because it's not blendable. All right? One interesting thing that we'll see from a naming convention. So naming convention. Interfaces are often named with ABLE at the end. Iterable, blendable, serializable, splitteratable. Now that's not a rule. You don't have to name them with a bull at the end of it, but that is a pretty common naming practice. which makes sense by my example a second ago with blenders, right? Things that go into blenders would be things that are blendable. So when you decide whether you look in the fridge, you decide what you should put in the blender, you have to think about, will that blend? What happened to that show? That was a YouTube channel, right? Will it blend? Remember that? Oh yeah, this guy had these high-powered blenders, and each episode he would just try to blend different things that were not blendable. But the whole thing was whether or not, his super awesome blender was good enough to blend it. They were blending rakes. They blended iPhones.
There's those smashing ones where they do like the hydraulic press ones, like where they try to press everything.
Well, yeah, but that's going to crush most things. But a blender?
Yeah.
Like whoever sits there and says, well, I wonder if I can blend this rake.
No one.
We knew it. Yeah.
For another
do.
naming convention, are they also commonly, do they normally have like an I in front of them as well?
Have an I in front of them. No, because like serializable, it doesn't start with an I. Is that what you're asking? Like, would it start with an I?
Yeah, I'm just thinking, at like the internship, for example, they use C# and
Yep.
every interface I've seen started with I.
Okay, can you give me some examples?
Like, for example, there's like a mapping interface, and for the interface for mapper, it would be iMapper, and everything I've seen has started with an I. I was just curious if that was just more a C# thing, or just
Could be.
specific
Yeah, it
word?
could be a C# thing where they kind of flag it with is it a lowercase I or an upper?
Uppercase I.
So they flag it with the uppercase I indicates this is an interface.
Mhm.
Yeah, I guess I can see it.
Okay.
So, the UBL standard that Java uses that I've actually seen in most languages, that is kind of like that telltale sign that this guy's an interface. So maybe what you're looking at is instead of the end part being in a bowl, they just throw an uppercase I at the beginning of it. So in the iterable version of that would be the I iterable or I iterer.
It would probably still be iterable. I'd
Okay.
imagine, but like just the I in front of it to establish that it.
Yeah, possibly.
I was curious.
Yeah, that sounds reasonable to me. It's not necessarily something I've necessarily seen. I wonder, is that something that they've implemented
It could be
internally?
that too.
It's their own
I think
naming
I've seen,
standard?
like some other things though. Like
Okay.
I don't know.
Yeah, it's entirely possible. Entirely possible. But so the caveat is always naming conventions are not hard and fast rules. But if you look at any interface that's built into Java, I'll just kind of cover my butt here and say that 99% of them will have an abol at the end of them in Java. Is there another question back there?
I was just wondering, did he actually succeed with the iPhone?
Oh, yeah. Every new iPhone that came out for a while for the show, they would see if they could blend it. Oh, it always blended it. And then the guy would look at it and says, iPhone dust. And then dump it out. Oh, yeah, it's on YouTube. Go and look it up later on, not during my class. Yeah, it's called Will It Blend. Probably had 100 videos of different things he tried to blend. Okay? But we would say as human beings that a brick is not a blendable thing. Right? It's not something you should put in your blender if you want your blender to survive. You wouldn't blend a brick, then rinse it out real quick, and then make a smoothie. Right? Like Mr. Gonzalez would, but normal folks would not. This is protein shake. It's a brick plus some toothpaste. That's breakfast. All right, so we kind of get where interfaces fit here. All right, so this for loop says we're going to go through every element in the debits. The element's currently called D. We're asking the question if D is equal to the month that we're currently on, whatever month was passed in here. So we're saying execute debits. We're going to go through all the debits that we have in our collection, looking to see if there was a debit for this month. Remember, we said we're making an assumption that we will not find more than one in a month. Because I'm only going through here, and the first debit I find for this month is the one I'm going to keep. So I gave myself a variable here called temp. I started equal to nothing, to null. And if I found a debit in here for the current month, I'll set temp equal to that debit and then break out of my loop. So now I'm here. my goal here is I found a debit, and now I need to take money out of my investment, because I need this to pay a bill. I need this to pay my, in this case, my alumni association bill. Okay? So this was what I was going to have you do for homework, but we didn't do it because you had the exam. Still have the exam, but all right. So if I'm in here, this means I have a debit I need to make. That's what this if statement says. If, well, I'll put it inside the if statement. So if I make it into this if statement, that means I found a debit in here that I need to process. What does it mean to process a debit? Well, it means to go through all of my, what do I call them? Contributions, all my current contributions, and try to remove money from that contribution. If I go into my contribution here, we wrote a function here called attempt to debit amount. So this guy takes in an amount of money along with a month, because we need to make sure that we don't take money from a contribution that has not happened yet. All right? So we asked the question, is the month associated with this contribution less than or equal to the month when this contribution was made? Okay, or the month I'm looking for. This says, has this contribution already been made? If the contribution has already been made, we're going to take the current amount, that's the amount plus interest that's been added to the contribution, right? Because over time, regardless of how many months this has gone through, we've potentially added interest onto a contribution. And remember, a contribution keeps track of two things: what the initial amount was, which never changes again, and then the current amount, which would change over time based on interest, right? All right, so I'm going to set what's left equal to the amount left in this contribution, which, remember, if we've already bled a contribution dry, this might be 0. Okay, but we'll say, hey, whatever this contribution is currently worth, I'm going to try to take away from it the amount of money I need to take away. If what I have left is a positive number, I did not fully drain this contribution dry. Okay, so I'll set the current amount for this particular contribution to my what's left value, what's happened to it after I've removed my contribution, after I've dwindled my contribution, and then I'll go ahead and return 0. That means that I have attempted to debit my amount, and I was successful in debiting this entire amount from this contribution. So I'm letting whoever called this know, you don't have to ask any other contributions for money. I was able to remove everything you asked for from myself. This is what's left, 0. Make sense? That's what I say in here. Now, if what's left is not greater than 0, that means it's 0 or less. Then I'm going to go ahead and I'm going to set the current amount to 0. I have dwindled this investment. Make sense? So if I was trying to take away $100 from a $90 current value, I'm at negative $10. That's not a real thing. You can't have a bank account or investment that has negative $10 in it. That means you owe the bank money. Okay? Any negative numbers in your bank account is bad news. you don't want that. All right. So I'll go ahead and 0 out my current amount for this particular contribution. It no longer has money in it. So keep in mind that in the future, when we go to apply interest to this guy, what will happen? I'll be multiplying 0 times the 0.67%, which will end up being 0. So applying interest won't have any impact on this contribution. So I can just leave I don't have to remove the contribution. I can just leave it in there as money I had previously put in for record keeping purposes. But this guy no longer grows. Because if you have $0 and it grows at 7,000% per minute, it will still always be 0. That would be a great return, though, if you had $1. Go ahead.
So this function is designed to tell you how much the person who owns that account is in debt.
This one function here is associated with a single contribution, not an entire investment, one contribution. And we are trying to remove some money from a single contribution. In the end, this guy will return as a double the amount of money that is left after we tried to remove this amount. If we were to fully fund that amount from this contribution, it would return a 0. If we were not able to fully fund that amount, we'll zero out this current contribution. There is no longer money left in this contribution. We'll zero it out, and then we'll return what's left times -1. So if after I try to take the money here, I was left with -$10, for example, I'm going to zero out this contribution, and I'm going to return -10 times -1, which will be 10. I did what I could. You still need somebody else to give you to give you the $10. I was only able to give you 90. Make sense? So I'm passing the buck to somebody else. This guy returns the amount that's left after he had tried to debit this amount from this contribution. Okay? Now, we only did all of this logic if the contribution I'm currently looking at was a legal contribution to consider. That is, this contribution had been made on or before the month in question. If it wasn't, I'm just going to return the same number that you passed in. You asked me to debit $100. This contribution does not happen for another 4 months. You need to find $100 someplace else. Make sense? I can't remove it from this contribution because this has not happened again. This is happened yet. This is a future contribution. All right, so that's what this tool does. I ask a single contribution to try to remove money from itself, and he lets me know how much is left after he did what he could. This is what's inside the box. That's the implementation. But if I go to Home Depot and I buy this one tool off the shelf called the Attempt to Debit Amount tool, I toss in an amount of money and the month that I'm trying to debit it, and he will spit out what's left that I still need to get for my amount I'm trying to debit. Make sense? So that's what that tool does. So now back here in our investment, if temp is not equal to null, that means I do have a debit I need to debit. So what I'm going to do is I'm going to go through potentially all of my contributions. So I'll say for contribution C in this dot the contributions. And then I will attempt to debit the amount associated with temp from that contribution. So I'll go ahead and say int amount is equal to temp dot amount. So that's the amount I am trying to, is this a double? That's a double. Okay, so here's the debit. I'm asking that debit for the amount. I'm going to go ahead and store that in a local variable here called amount. And actually, if we want, we can call that amount left. So at the very beginning, the amount left is the full amount that we're trying to debit. Then I'm going to go into each contribution. I'm going to set amount left is equal to C dot try to, what did we call it in our contribution? Attempt to debit. C dot attempt to debit amount what amount? Amount left from what month? The month that was passed in here. Month. Okay? Then we can ask the question, if amount left is equal to 0. Now, I could let it go ahead and keep going. I could just say, hey, I want to debit $0, and this will just say, yeah, you're good, right? But I can break out, not waste time. I'll say, look, if after I tried to debit from C, I no longer have anything left I need to debit, I'll go ahead and just break out. That makes sense? Now, one of two things have happened. I have either successfully debited the amount or I'm out of money. I've gone through all my, so I either unnaturally broke out of my loop here. That means I am done debiting. How many T's are in debiting? And have succeeded. So that's what we do there. But I could also end this loop by running out of contributions to take money out of. Right? Kind of think of it like in your house, you have money hidden all over the place and you've run out of places to look. Okay. I still need $6 to pay the power bill and I've looked everywhere. Amount left is $6. All right, so we can ask a little question here. If amount left is greater than 0, we can print out a little statement. Maybe we'll do I'll show you another thing. System.error.println. I ran out of money. All right. And system.err instead of system.out will show up in red in Eclipse's thing. All right, so usually when we print stuff out, we say system.out.println. Most computing systems have two different output streams. We have a normal output stream, system.out, and then we have an error output stream, system.err. And the reason why we have two is for logging purposes on operating systems. We can choose to have system.out direct to the screen and system.error direct to some file that shows you all errors that have occurred. So you can kind of deal with the idea is that anything that gets printed out on system.error is problematic stuff. For anything that gets put out on system.out is just informational for human consumption stuff. So that's why most of the modern operating systems split those two, so you have two different ways of displaying stuff. It's still just displaying, as I'm using it right here, it's just going to display it to the screen. Okay? So that's what execute debits does. For a given month, it finds if there is a debit that needs to be executed. If there is, it goes through and it executes it, and either drains your money a little bit or drains your money completely. If it drains your money completely, it lets you know you're out of money. Make some sense? All right, so we'll go out to investment now. I'm sorry, we'll go out to driver. Actually, we are still on investment. We're going to get current value, right? So get current value says how many months we're going to run this for. Then we're going to have our percentage. We're going to go through all the months. The beginning of each month, we execute any debits that should occur. Then we grow our investment. We do that for some number of months. Then we go through and we get our current total. And it goes through all the contributions, get the current amount given a month, and we return that total. The idea should be this is the money we have left after we invested $1,200 and once per year we spent $100 on our alumni association thingy. So what do we have a prediction? Is it going to, will we have enough? Or do you think we're going to run out of money? So this is $1,200 day one. And then in 12 months, we take out 100. But every month it's growing. 12 months later, we take out another 100. But every month it's growing. Is $1,200 initial investment enough to sustain our $100 a year alumni association forever? You think so? Let's find out. We made $102. So by Pastor Smith choosing to only pay per month, at the end of 13 years, he has $102 more than he originally put in by debiting it every single month. Now, let's fast forward this. That's for 12 years, right? So let's do this over 30 years. So 30 times 12 is 360 months. Still sustaining, still making a little money. Make sense? Now, we are relying here on the fact that the Alumni Association doesn't raise the price for them. Okay, but we see that he was incorrect in his assumption during his sermon that, hey, if I had only given them $1,300 at the very beginning and had my lifetime membership, I would have been better off than I am right now, having to pay them $100 per year. But in actuality, if he had given them $100 plus invested $1,200, as long as he was getting the 8%, which is a big if, right? You know, this isn't a guaranteed thing. If that first year was a bad year, he may have dwindled his money too much. That might have been this isn't a guarantee, but it's plausible, more than plausible, let's say. So he would have come out ahead. Make sense? All right. Now we can see something interesting here. What if he had said, I'm going to go ahead and invest $2,000 at the beginning? Look how much more he has now. Because he had more. So he only invested $800 more. But at the end of 30 years, he made $8,000. What if he just did $100 more? Almost doubled his money instead of being up by 100. Make sense? Invest while you're young. That's the punchline of this. Talk to your finance teacher. I'm happy to teach you about this stuff too. I teach success seminar stuff on this kind of thing. But yeah, these are important skills, and your greatest strength right now is your age. So you got a lot of years left on this earth, and even if you can only put in $20 a month or something like that, even now, you saw how little of a difference it took before that had drastic changes in your growth, right? All right, so no homework over the weekend, but you do have the midterm done, due by midnight tonight, and there is a risk of a quiz on Tuesday covering what we've talked about last class and today. All right, those are things that are not represented on the exam. All right, I will see everybody on Tuesday.